Hello everyone, welcome to Chemazon-Complete Chemistry. So in today's video, we are going to solve another question of the difficult question series. So here you can see a reactant is given to us and there are a lot of reagents that is given and we have to identify the product P. So it looks difficult, but actually if you do step by step, it is not very difficult. So let us first start with the reactant. What is the reactant that is given? It is an alkane. Okay. Then alkane 2-methyl propane. What is the first step? Reaction with Br2 in presence of light. So whenever heat or light is given, remember which reaction takes place. The mechanism followed is a free radical mechanism. Okay, free radical mechanism. So first step is formation of a stable free radical. What is the order of stability of free radical? Tertiary greater than secondary greater than primary. So what is a tertiary radical? Carbon having an unpaired electron and 3 other groups. Okay, this is a tertiary radical. So is this radical formation possible in the reactant? Answer is yes. This CH bond we can break homolytically. Homolytic means the atoms forming the bond, both the atoms will get 1 electron each. So what we get is a tertiary radical, stable tertiary radical. Okay, this is the tertiary radical that is formed is stable. Okay, and along with that, this Br-Br bond will also break homolytically or cleave homolytically, and we will get Br radical. This tertiary radical, tertiary butyl radical, will react with bromine radical to form tertiary butyl bromide. Okay, now what is the first step is completed. Okay, first step is completed. Now the next step is reaction with tertiary butoxide. Now what is a tertiary butoxide? Tertiary butoxide is carbon attached to 3 methyl groups. Okay, that is tertiary butyl, then O minus and K plus. This is potassium tertiary butoxide. So initially it was alcohol tertiary butanol. This reacted with base, that is KOH, and it formed this strong base, that is potassium tertiary butoxide. It is also written as KTBuO minus, like this. TBU means tertiary butyl group. So this is a strong base. Now the question is, in presence of base we know elimination reaction takes place. Now the question is, which elimination reaction takes place, E1 or E2? So what is the first step? First step in any substitution or elimination reaction is you have to draw the carbocation. Okay, form the carbocation and check whether it is stable or not. Okay, if the carbocation is stable, that is a tertiary carbocation, then the mechanism followed is with the subscript 1. Okay, and if the carbocation is unstable, let's say it is a primary carbocation, then the superscript is 2. Let's say it is elimination, then we are talking about E1 and E2. If it is a substitution, then it will be SN1 or SN2. So here if I remove Br minus, what I will get is a tertiary carbocation, which is a stable carbocation. Okay, tertiary carbocation which is stable. So which mechanism will be followed here? E1. Okay, and any one of the alpha hydrogen will be abstracted. What is alpha hydrogen? This is a carbon having positive charge. The carbon next to that, this is alpha, this is also alpha. So hydrogen attached to alpha carbon is alpha hydrogen. So any one of the alpha hydrogen will be abstracted by the base. Okay, 3 methyl group. So this will abstract this proton, and what we will get is a alkene, double bond CH2. Okay, so our second step is also completed. Next step is reaction with MCPBA. What is MCPBA? Metachloroperbenzoic acid. MCPBA, metachloroperbenzoic acid. What is benzoic acid? Benzoic acid is benzene, C double bond OOH. Now, metachloro means at the meta position there will be chloro. So these are ortho. Next to that, these are meta position. This is para. So meta position there is chloro. Per means peroxy linkage is present. Peroxide is present. That is what? Oxygen bond. So what will happen here? There will be another extra oxygen. Okay, this is the structure of MCPBA. Okay, metachloroperbenzoic acid. Okay, so what will be the product? The product will be epoxide ring. What is epoxide? Three-membered ring with oxygen as the heteroatom. So our third step is also completed. Okay, so okay, let me write. Okay, so first three steps are completed. What was the product that was formed after epoxidation? It was this. This was the product. Next step is reaction with Grignard reagent, pH, MgBr. Now, Grignard reagent, there are two roles. One is either it can act as a nucleophile or it can act as a base. So here, this will act as a nucleophile, that is electron-rich species. So it will attack from the less hindered side. So here you can see there are bulky methyl groups. So the attack will not take place from this side. The attack will take place from this side. This will attack here, will become O minus, and that O minus will pick up proton, and what we will get is a alcohol. Okay, alcohol, two methyl groups. Then there is this carbon, okay, this carbon, and then pH. pH, CH2, C, CH3, CH3, OH. These are CH3. Okay, so our fourth step is also completed. Okay, next step is reaction with HCN. How will that take place? H, C, triple bond, N. Now this is more electronegative, right? Cn minus. So what will happen here is oxygen has a lone pair. Here again substitution reaction will take place. First step is this will get protonated. Cn minus will go away as a leaving group. Okay, Cn minus goes away as a leaving group, and this will be protonated, positive charge. Now what is the next step? This will act as a nucleophile, and water will go away as a good leaving group. So loss of water molecule, what we will get is cyanide. Cn methyl methyl CH2 pH. Okay, what is the next step? Now fifth step is also completed. Next step is hydrolysis. Hydrolysis means reaction with water, and which bond will break? CN bond will break. So this is like this. Okay, hydrolysis of cyanide will form what? It forms carboxylic acid. C double bond O OH. Methyl methyl CH2 pH. What this reaction is? Hydrolysis of cyanide to form carboxylic acid. Cyanide, or we can say nitrile. Cyanide, hydrolysis of cyanide forms carboxylic acid. So sixth step is also completed. Next is reaction with alcohol. CH3OH and H2SO4. This is the acid. Acid is a catalyst. Okay, so what will happen? There will be loss of water molecule. H will be removed from here, and OH from here. We will get what? We will get an ester molecule. O, CH3, two methyl groups, CH. Okay, this is the ester molecule. Okay, so seventh step is also completed, and the last step is reaction of this ester with Grignard reagent, that is ethyl magnesium bromide. So what is the first step? This will attack Et minus. Okay, we know RMgX, R is minus, Mgx is plus. This is more electropositive. This is less electropositive, or we can say R group is more electronegative. So it will get negative charge. So Et minus, it will act as a nucleophile. It will attack. This will open up. What we will get? Ethyl group is attached. What is ethyl? CH2 CH3. Right? CH2 CH3. This will be O minus. This O minus will come back. The good leaving group OCH3. What we will get is we will get a ketone. CH2 CH3. Then we have CH2. Okay, sorry, I missed one carbon here. It is CH2PH. CH2PH. So this is a ketone, and One more equivalent of Grignard reagent can attack here, and what we will get is this will become O minus. Okay, O minus, and one more ethyl group has attached here like this. Now this O minus will react with water, and it will, the final product will be a tertiary alcohol. O minus will become OH. So this is our what? This is our final product. This is our final product P. Okay. So in this way, if you solve step by step, it is not very difficult. So we learned a lot of different concepts. Which all concepts we saw? First step was, this was free radical bromination. Right, multiple reactions were involved. This is very good for revision. Second reaction was elimination. Which elimination reaction? E1. Then we saw epoxidation. This was formation of the epoxide. Okay, epoxidation. Then this was reaction with Grignard reagent. Okay, then another substitution reaction. Okay, then hydrolysis of cyanide. What was formed? Carboxylic acid. And then last step, this was which reaction? Formation of ester. Reaction of carboxylic acid and ester. This is called as what? This is called as esterification reaction. Okay. And last step was reaction with RMgX, that is Grignard reagent. The final product P, what? It is this product that we have got here. Okay, so I hope you have understood all the steps of the reaction and all the intermediate products. Thank you.